right, let's move on to another example. Let's sketch the graph of the curve defined by these parametric equations. X equals sine of t, y equals sine squared of t. So how do we do this? Well, we can start by eliminating the parameter t. The reason I'm going to do this first is because I see that both x and y involve this function sine of t, so maybe I can get rid of t altogether and just express x in terms of y. So what do? Well, we eliminate the parameter t, so y is sine of t all squared, but sine of t is x. So that means we get y is equal to x squared. So the parametric curve lies on the parabola y equals x squared. So let's sketch that one out here. We've got this parabola y equals x squared. Now at this point, I don't know how much of the parabola is traced out by the parametric equations. Can I get any point on the parabola by taking an appropriate choice of the parameter t? Well, no, because x is sine of t and y is sine squared of t, and I know that sine doesn't get any bigger than 1 or any smaller than negative 1. So notice that x, which is sine of t, has to live between negative 1 and 1. So why is that? Well, that's sine of t. So it's bounded by negative 1 and 1. And y, which is the square of sine of t, has to be a positive value because it's being squared and smaller than 1. And so that's because that is sine squared of t. So I know that the points on the curve live on the parabola between negative 1 and 1 and 1 and 1. So I know the x-coordinate doesn't get any bigger than 1. The y-coordinate doesn't get any bigger than 1. The x-coordinate doesn't get any smaller than negative 1. And so it's got to live between these 2 points. So it's got to be on this portion of the parabola. So the points on the curve lie on the parabola, or live on the parabola between these 2 points. So that means the curve consists of only a portion of the parabola. And since t went from negative infinity to infinity, we don't have a terminal point and we don't have an initial point. But we can see what happens for different values of t. So when t is 0, I'm at the origin, 0, 0. What about when t is the next value for which something interesting happens? Maybe when sine is 1. So that's when we get to what, pi by 2. So when I hit pi by 2, I'm up here. And then I come back. And then I hit the origin again at pi. So I've moved up, and then I've come back. And then when I hit 3 pi by 2, my sine of 3 pi by 2 is negative 1. And then the y value is negative 1 squared, or 1. So I'm up here at t equals 3 pi by 2. And then I come back down. And I'm here at 2 pi again. And I just keep oscillating along the parabola between these points 1, 1 and negative 1, 1. So the curve consists of points of only a portion of the parabola, and as the parameter t increases, the points oscillate on the parabola. All right, so we can have a look at this. Here I've done a quick sketch where as our t values increase, I started at t equals 0, but we can just see what happens. As t increases, we bounce back and forth, and back and forth. So you can see it traces out the portion of the parabola trapped between -1 and 1 on the left and 1 and 1 on the right.